Okay, so here we have part 3 of our College Algebra sample final exam review. Number 17, we're sketching the graph of x squared minus 2x minus 3. It's a quadratic. Okay, we know the shape of a quadratic is a parabola. Okay, we know that we have our a value is positive. Right? For a value that's positive, we know it's going to be opening upwards. Okay, so let's get right down to it. The most important point in the parabola is the vertex, right? We need to identify the vertex. So for us, when it's in standard form, we want to first get the axis of symmetry, which would be our x equals negative b over 2a. Okay, so we know that b is negative 2 already, so let's see, we have negative of negative 2 all over 2 times a. A is 1, so this will be a positive 2 over 2, which is equal to 1. Okay, so that means x equals 1 would be our axis of symmetry. Right? AOS, axis of symmetry. That means our vertex would be 1 comma, we don't know, right? So we need to plug the 1 in to our function to figure out the y value. So 1 squared minus 2 times 1 minus 3. So that's going to equal 1 minus 2 minus 3. So what does that give us? That's 1 minus 5, so negative 4. So 1 comma negative 4 would be our vertex. Okay, so that's important. Some other intercepts. Okay, we need a x-intercept. I'm going to have a couple of those. Let's see. X-intercept. Remember the y is 0. So we can just set our equation. X squared minus 2x minus 3 equal to 0. This one we could factor. Right, so x minus 3 and x plus 1. Right, what multiplies to negative 3 and adds up to negative 2. So negative 3 and a positive 1. And so that means x equals 3 and x equals negative 1 are two x-intercepts. Okay. Y-intercept. Y-intercept, that means x is equal to 0. So that means we have 0 squared minus 2 times 0 minus 3. So that's 0 minus 0 minus 3. So for y to be equal to negative 3, that would be our y-intercept. Okay, so let's graph it. So we know we have 1, 2, 3, 1, 2, 3. And then we have 1, 2, 3, 4. So 1, negative 4. And then we have y-intercept of negative 3. We have x-intercepts of 3 and negative 1. Okay, so we have everything going here. Okay, that's our vertex. So it's going to be opening like this. Okay, and that's our graph. Okay, let's take a look at our next one. Sketch the graph of f of x. Okay, it looks like it's a cubic, right? X times x times x, that's x cubed. It's a polynomial. Okay, so let's get our intercepts. So y-intercept, remember, is when x equals 0. So that means we would have f of 0, so 0 plus 1, 0 minus 1, 0 plus 3. So 1 times negative 1 times 3, which is negative 1 times 3, negative 3. So that's our y-intercept, right? 0, negative 3. X-intercept, we just take our function, set it equal to 0. So x plus 1, x minus 1, x plus 3. And set each factor equal to 0, right? So x plus 1 equals 0, x minus 1 equals 0, x plus 3 equals 0. Okay, so x equals negative 1, x equals positive 1, and x equals negative 3. Okay, so those are our three x-intercepts. Okay, so now what we want to do is find out what's happening around them, right? Around these x-intercepts. Okay, so let's plot these like on a number line style. Okay, we have, say 0 is here, 1, 2, 3, 4, 1, 2, 3, 4, and then negative 1, negative 2, negative 3, negative 4. Okay, and our zeros, negative 3, negative 1, 1. Now, we normally plot points around these zeros. Okay, so we would look to plot points at negative 4, negative 2, 0. 0 we have already actually, 0, negative 3. And then at 2. This way we get some better idea of how the points are going as far as, graph-wise. All right, so let's plug these in. So negative 4, we plug into the original function. So we would have negative 4 plus 1, negative 4 minus 1, negative 4 plus 3. Okay, so that gives us negative 3, that's negative 5, and that's negative 1. So that's 5. That's 15 times negative 1, negative 15. Okay, so negative 15. Plug in negative 2, negative 2 plus 1, negative 2 minus 1, negative 2 plus 3. So that gives us negative 1, negative 3, and positive 1. So that's 3 times 1 is 3. Okay, let's plug in 2. 2 plus 1, 2 minus 1, 2 plus 3. So 2 plus 1 is 3, 2 minus 1 is 1, and 2 plus 3 is 5. That's 15. Okay, so let's go ahead and graph them. Negative 4, negative 15. So you're estimating at this point, negative 4, negative 15, let's say, is here. Negative 2, 3. Negative 2, 3 is, let's say, here. 0, negative 3. 0, negative 3 is, let's say, here. So this is negative 2, 3. 0, negative 3. And then we have 2, 15. Okay, and now we can just connect the points. Go through your zeros. Okay, so there is our cubic function. Okay, and try to put some fluidity to it, like make it curved, as you approach those turning points, right? If it's third degree, we know there's 2 turning points, right, at most. So all those things, positive value for our A, okay, and the end behavior fits, right, for a cubic. As x approaches infinity, so is the function. As x approaches negative infinity, function approaches negative infinity. Okay, so all those things match up. All right, let's go on to our next one. Sketch the graph of f of x equals 6 over x plus 2. Okay, rational function. So first order of business, we need to make sure we tackle the vertical asymptote, okay, which is based off of our denominator. Right, so set the denominator equal to 0. Solve for x, so x equals negative 2. That is our vertical asymptote. Okay, and now what we need to do is graph points around the vertical asymptote to figure out what's going on. Okay, so for our graph, we know the graph will look like this. When we get to negative 2, there is our vertical asymptote. Okay, now we need to graph points around that vertical asymptote. Okay, so let's make a table. So around negative 2, so negative 3, 4, 5. Let's do negative 3. Let's do negative 4. Around this way would be negative 1 and 0. Okay, now we're just going to plug in. I just plug into the function. So we have 6 over negative 3 plus 2. So 6 over negative 1. So negative 6. 6 over negative 4 plus 2. 6 over negative 2. So negative 3. 6 over negative 1. So that's negative 6. And then 6 over... Oh, wait, hold on. 1 second before I go ahead of myself. Let's plug into that denominator. Negative 1 plus 2. So 6 over negative 1 plus 2 is a positive 1. So that's a positive 6. Always make sure you're plugging in, otherwise you're going to make mistakes. And then 0 plus 2 is 2, so 6 over 2. And that gives us 3. Okay, so for our graph, negative 3, negative 6. So negative 3, negative 6. Negative 4, negative 3. Okay, negative 1, 6. And then 0, 3. Okay, so this one will look like this. And then this side of it will look like this. Okay, so intercepts wise, we have a single y-intercept, right? So 0, 3 is our y-intercept. We have vertical asymptote, and then this x-axis is actually our horizontal asymptote, right? You want to think about what happens as x gets really, really large. Like if this was, let's say, 100. So now we have 6 over 100 plus 2. So 6 over 102. That would be something very small, right? So it's going to get closer to 0. And if we do on the other side, if we're going negative 100, so that would become 6 over negative 100 plus 2, negative 98. You can reduce each of these. Now that would be something very small on the negative side. Okay, so that would be close to 0, but from approaching 0 from the negative side. Okay, so that's what we would end up with as far as our graph for the rational function. Okay, and don't forget to mention the horizontal asymptote, like we said. Horizontal asymptote would be y equals 0. Okay, let's take a look at our next one. Find the inverse of the function of the matrix. Okay, so if the matrix is A, B, C, D, remember what we said for inverse. Inverse would just be 1 over the determinant times, and now the matrix would get, A and D would get switched, right? We have D and A, they just switch positions, and then B and C would just change signs. Okay, so that would be our blueprint for getting our inverse. Let's show the work for the determinant. So we have 4 times negative 3, right? Main diagonal, minus negative 1 times 2. So that gives us negative 12 minus negative 2. Negative 12, double negative, plus 2 is negative 10. So that means we have, for our inverse, negative 1 over 10. And now let's switch the A and the D. So negative 3 up here and 4 down here. And then we switch signs. So negative 2 here and positive 1 here. Okay, so this would be our inverse. Okay, if you wanted to distribute the 1/10, the negative 1/10 into the matrix as a scalar multiplication, you can, but you could also leave it just like this. Okay, all right, let's take a look at our next one. Solve the system by first changing to an augmented matrix and then perform row operations to put the matrix in reduced echelon form. Okay, so let's do that. Let's put into matrix form. So we have negative 2, 2, negative 6, 1, 3, negative 5. Right? I'm getting these numbers just from our coefficients and constants. Right? Negative 2, 2, negative 6, 1, 3, negative 5. Okay, now the goal, remember, is to get that identity to appear, and then whatever we get for x and y, we would end up with that term. So what we want to do is ideally get the 1 in the upper left corner. So I could swap these two rows, right? So 1, 3, -5, -2, 2, -6. Okay, once I get that, I want to get the 0 down here, bottom left. Okay, so the only way I could do that is if I multiply the top row by 2. So 2 times row 1 and add it to row 2. That would give me the 0 down here, and that would become my new row 2. Okay, so 2 times row 1 would just be 2. 2 times 3 would be 6. 2 times -5 would be -10. I'm adding to the bottom. Okay, so that gives me 0, 8, -16. Okay, so that gives me 1, 3, -5. And now my new row 2, 0, 8, -16. Okay, so now next we want to get the 1 down here in the bottom middle. Okay, next what we want to do is get a 1 in this spot right here where the 8 is. So the way we could do that is just multiply by 1/8. And we have 1/8 row 2, and that'll be our new row 2. Okay, so that gives us 1, 3, -5, and then 0. 1/8 times 8 is 1, and 1/8 times -16 is -2. Okay, and now that we have that, we can easily get our 3 to become a 0. So we'll just do -3. Let's see, -3 times row 2 and plus row 1, and that'll give us our new row 1. All right. So we have this -3R2, right? -3 times the second row plus the row 1, and that'll give us a 0 in this upper middle uh, position, right? So -3 times row 1 will be 0, -3, and +6. We're going to add to it row 1, so 1, 3, -5. And that'll give us 1, 0, and 1. Perfect. Okay, so here's our new row 1. So we have 1, 0, 1, and then we have 0, 1, -2. So what does this mean? This means x equals 1 and y equals -2. So 1, -2 as a solution. Very nice. So we'll continue with another part very soon. Hope to see you soon. Have a great day.